Look at your skin right now. Whatever shade it is, pale enough to burn in 20 minutes of sun, or dark enough that sunscreen feels almost optional, that color wasn't an accident. And it was never really about beauty. It's the record of a fight your ancestors had with the sun, going on for hundreds of thousands of years, long before anyone called it a race. Here's the strange part. Every human alive today started from the exact same ancestors, in the exact same place, under the exact same sky. And somehow, that one starting point produced almost every skin tone you can imagine, not because one version is more evolved than another, but because of a vitamin your bones literally cannot survive without, and a star, 93 million miles away, that's been quietly rewriting the color of human skin depending on exactly where people happen to stand. So, why do humans come in so many different colors? The answer isn't really about skin, it's about how far your ancestors traveled from the equator and what the sun tried to do to them at every stop along the way. That's the story I want to show you. Because once you understand it, something as ordinary as a family photo or a stranger's face on the street stops looking random and starts looking like a map of everywhere your ancestors have ever stood. But to understand that, we have to go back to a body that had almost nothing standing between it and the sky above. That body belonged to an early human standing in East Africa roughly 300,000 years ago, a body with almost no hair left to cover it, skin damp with sweat, with nothing standing between bare skin and the sun above except a few feet of open air. And that was the problem. Skin is not a simple wrapper. It is an organ, the largest one you have, and in that world, its job was to stand between your DNA and a star that did not care whether you survived it. That star fires ultraviolet radiation at Earth constantly, and UV light does not so much warm the skin as attack it, breaking chemical bonds, rewriting strands of DNA. Enough of that damage in the wrong place for long enough has a name: melanoma, one of the most aggressive cancers a human body can develop. The earliest members of our species lived under some of the strongest sunlight on the planet, not occasionally, but as daily life. No sunscreen, no hats, no walls to duck behind, just skin day after day for an entire lifetime. The body's answer to that problem is a pigment called melanin, and calling it a sunscreen is not much of an exaggeration. It absorbs and scatters UV radiation before it can reach the DNA sitting underneath. And the more of it a body produces, the darker the skin, and the better shielded the DNA inside it. That was not a small effect. Populations that lived closest to the equator for the longest stretches of time developed the highest concentrations of melanin on the planet. And that was not a coincidence. It was natural selection running the same experiment under the same sun for thousands of generations in a row. But the sun had a second weapon, and it had nothing to do with cancer. UV radiation also breaks down folate, a B vitamin the body needs to build new cells and repair damaged ones. In a pregnant woman, folate is critical in the first weeks of fetal development, often before she even knows she is pregnant. And without enough of it, the neural tube that becomes the brain and spinal cord can fail to close properly. Less melanin meant more UV reaching the bloodstream, which meant more folate destroyed, which meant a measurably higher rate of lost pregnancies. Under the equatorial sun, natural selection did not treat dark skin as a preference. It treated it as a requirement, enforced twice over, once through cancer, once through reproduction itself. For a very long time, that should have been the whole story. Dark skin worked. It protected DNA, it protected folate, and it protected the chance to have children at all, and to pass that advantage forward. Then, humans started moving. Not all at once, and not as one great migration. More like a slow leak, one generation stepping a little farther than the last. Out of Africa and into the Middle East, into Europe, into the cold stretch of Northern Asia. And somewhere along that slow drift, the sky itself changed. The sun did not get weaker. It just stopped hitting them directly. At higher latitudes, sunlight arrives at a lower angle, filtered through more atmosphere, blocked by clouds and short winter days for months at a time, and the UV that had been a constant threat in Africa became, up north, something closer to a rare resource. The same melanin that had kept their ancestors alive under the African sun was now working against them. Here is the problem nobody in Africa ever had to think about: vitamin D. Skin makes vitamin D by using UVB radiation to convert a compound sitting just under its surface, a solar panel, in the most literal sense. Without enough UVB reaching the skin, the body struggles to make vitamin D on its own, unless diet supplies what sunlight cannot, and vitamin D is not optional. It controls how the gut absorbs calcium, and without enough calcium, bones stop forming correctly. In children, severe deficiency produces rickets, a disease that bows the legs outward, softens the skull, and stunts growth for life. In adult women, it can soften the bones of the pelvis badly enough to make childbirth extraordinarily dangerous, sometimes fatal, and it weakens the immune system and affects muscle strength, besides, so a body running short on it tends to fail quietly, in several places at once, long before anyone thinks to blame the sun. Bring African level melanin into a Scandinavian winter, and the shield becomes the barrier. The same defense that once protected folate and DNA now blocks the one thing the body needs to build a working skeleton. Generation after generation, in that specific environment, the math flipped. Slightly less melanin meant slightly more vitamin D, which meant stronger bones, safer childbirth, and more children who lived long enough to have children of their own. Natural selection, which had once strongly favored dark skin, quietly began rewarding the opposite. But no one watched this happen. No parent ever looked at a child and saw evolution in progress. It moved too slowly for that. One birth, one death, one slightly better set of odds at a time, spread across so many generations that nobody living through any single one of them could have noticed their community's skin slowly changing shade. For decades, scientists assumed this shift happened slowly and steadily, over tens of thousands of years. Then, ancient DNA made the story stranger. In 2018, researchers analyzed the genome of a man who lived in what is now Britain roughly 10,000 years ago, a specimen known as Cheddar Man. He had blue eyes. He also had dark to medium dark skin, a combination that looks almost backwards to modern eyes, because we associate blue eyes with pale skin. But 10,000 years ago, that pairing was completely normal. Populations that had already lived in northern Europe for tens of thousands of years still had not fully lightened. The pale skin, now considered typical of northwestern Europe, appears to have spread widely only in the last 6 to 8,000 years, a sliver of time inside a 300,000-year story. It was farming. The Neolithic Revolution, the switch from hunting and gathering to agriculture, changed the diet first. Hunter-gatherers ate fatty fish, organ meat, and shellfish, foods naturally rich in vitamin D, while farming populations ate mostly grain, and their dietary vitamin D did not just drop, it nearly disappeared, leaving their skin alone to make up the entire difference. But food was only half the story. Farming did not just change what people ate, it changed how many people lived close together. A useful mutation no longer had to survive inside one small, scattered band. It could pass through marriages, children, cousins, and neighboring villages, a human network far larger and more connected than anything hunter-gatherers had ever lived inside. Diet removed the vitamin D that skin used to get for free, and numbers gave the mutation a highway to travel on. Together, they turned a slow, multi-thousand-year drift into something fast enough to leave a clear signature in the genetic record. But the map was never that simple. Some Arctic populations lived at extremely high latitudes for thousands of years without ever developing very pale skin, and the difference was diet. Traditional Arctic diets were built around fatty fish and marine mammals, foods already loaded with vitamin D, the same nutrient the weak northern sun could barely provide. If food already supplies what skin usually has to manufacture, skin does not need to change as much to compensate. Sunlight sets the pressure. Diet can cancel part of it out. That is why you cannot look at a latitude on a map and predict a skin tone with any real confidence. There are patterns, but never a straight line. And skin was not the only trait still being quietly rewritten. Every person alive today with blue eyes descends from one person, carrying one mutation that appeared near the Black Sea only 6 to 10,000 years ago. Younger than farming, younger than the wheel. It is a small detail, but it makes a large point. The combinations of traits we treat as ancient and fixed are often far more recent than they feel, and skin color followed the same rule. It was never locked in once and for all in the deep past. It kept changing as food, sunlight, migration, and population size kept changing around it. Here's the detail most people never hear about skin itself. There is no single gene for skin color, light, or dark. Pigmentation is controlled by dozens of genes working together, shaping how much melanin is produced, what type, and how it spreads through skin cells. And when different populations independently evolved lighter skin, they did not even use the same genetic solution to get there. The variants responsible in East Asia are largely different from the variants responsible in Europe. Two populations on two continents arriving at the same answer through completely different biological routes. That is called convergent evolution, and it is about as strong a signal as biology can give that a trait truly mattered for survival. And this is where the idea of race begins to break. Skin color shifts gradually across geography, shaped by sunlight, migration, and diet, layered on top of each other over tens of thousands of years, not by clean lines separating one kind of human from another. Walk from Central Africa northward 10,000 years ago, and you would not cross a border where humans suddenly changed. You would see a gradient, shaped by whatever combination of sun and food each population happened to inherit. The categories came later. The biology came first. So here is the actual answer. Skin color was never a ranking system, and it was never really about beauty. It is a dial, your body's best inherited estimate of how much sun protection it needs, set by the exact patch of the planet your ancestors stood on for thousands of generations, and by what they happened to eat while they were standing there. Dark skin is not primitive. Light skin is not advanced. Dark skin is the ancestral state, the baseline every human being started from 300,000 years ago. Lighter skin is the newer variation, the adjustment that only showed up once a population moved somewhere the old rules no longer applied. The sun did not choose sides. It simply radiated indifferently in every direction. And evolution spent 300,000 years sorting out who needed how much of it. None of that pressure has disappeared. It has just been muffled by sunscreen, by vitamin D supplements, by grocery stores stocked with food from every latitude on Earth all year round, by electric light that lets you spend entire seasons barely touched by the sun at all. Your body still runs the same ancient calculation it always did. It just has fewer consequences now. When that calculation gets the answer wrong, a vitamin D deficiency today ends in a doctor's note and a bottle of supplements, where 10,000 years ago, in the wrong body, in the wrong place, it could end a pregnancy or a life. We didn't fix the problem, we just built enough buffers around it that most of us never have to notice it is still there. Which brings us back to that family photo, or that stranger's face on the street. Every shade sitting in it is a record, written directly into melanin, of exactly which patch of sunlight someone's ancestors spent the most time standing under, and exactly what price their bodies paid, generation after generation, to get that balance right. Every skin tone alive today is an answer to a question the sun has been asking for 300,000 years, and every single answer was correct. So, why do humans have different skin colors? Not because of race, and not by accident, because of where your ancestors happened to stand under one very demanding star, and what they ate while they stood there. Every skin tone on Earth is proof of the same journey, taken in different directions. Underneath the color, it's the same species, solving the same problem, over and over, everywhere it went. You're not looking at difference when you look around a crowded room. You're looking at 300,000 years of migration, written directly onto skin. Look at your own family for a second. How many different skin tones show up in it? Tell me in the comments. I read every one. If this is the kind of question that keeps you curious about your own body and where it actually came from, that's exactly what this channel is for. A new one every week. See you in the next one.